Hello Candles, welcome to Candela Learnings. This is Rose, your chemistry tutor. Are you all ready for the second session of this chapter? Okay, now let's go through the second session of acid, bases and salts. Sometimes the elders in your family might be saying they are suffering from acidity. Now what is an acidity? Acidity, commonly known as acid reflux, is a condition in which excess acid is produced in our stomach. And as a solution for this, they might be asked to take antacids. Now, how an antacid will give a relief to acidity? What might be the chemistry behind that? To understand about this, let's do a small experiment. And for this experiment, we need an acid and a base. Can you tell one acid and a base that is very familiar to you? Okay, let's take sodium hydroxide and hydrochloric acid. And let's do a simple experiment. Let's add this sodium hydroxide to this hydrochloric acid in a beaker together. What will happen? What reaction will be taking place there? Okay, when an acid reacts with a base, we will be getting a salt and water. This reaction is known as neutralization reaction. In neutralization reaction, the effect of acid gets nullified by the base and vice versa. This is one of the chemical properties of acids and bases. Now what are the other chemical properties of acids and bases? Let's explore together. Now let's discuss the second properties of acids and bases, that is reaction of metals with acids. And for this we need a test tube, stand to support this test tube, a beaker containing soap solution and a few zinc granules, dilute sulfuric acid, a delivery tube and a cork to close the test tube. Let's perform this experiment. After setting up the experimental setup like this, let's add zinc granules to the test tube. Now what do you observe near the surface of zinc granules? Yes, you can see gas bubbles are formed near the zinc granules. Now what is this gas? Which gas is evolved in this reaction? Let me tell you, it is hydrogen gas. How will we confirm that this is hydrogen gas? And for this, we have to pass the gas evolved from this reaction mixture to a delivery tube and from the delivery tube to the beaker containing soap solution. Now the gas bubbles filled with soap is formed from the beaker. After showing a burning candle near to the soap bubbles, the gas burns with a pop sound. This confirms that the gas formed is hydrogen gas. That is, when dilute sulfuric acid reacts with zinc, we will be getting zinc sulfate and hydrogen gas. Or in general, we can tell that when a metal reacts with acid, we will be getting a salt plus hydrogen gas. Now what about base? What happens when a base reacts with metals? When a base reacts with metal, we will be getting the salt and hydrogen gas. For example, sodium hydroxide. When sodium hydroxide reacts with metal, we will be getting sodium zincate and hydrogen gas. However, this reaction of base with metal is not possible with all bases or all metals. This is the second property of acids and bases. Now let's move to the third chemical property of acids and bases, that is reaction of metal carbonates or metal hydrogen carbonates with acids. To understand this better, let's do one more activity. For this, you need a test tube containing dilute hydrochloric acid and another test tube containing lime water. And the experimental setup will be like this. After setting up the experimental setup, you need to add sodium carbonate crystals to the test tube. You will be seeing a colorless gas is evolved with so much evolution of gas. And the gas formed is passed through lime water that is taken in another test tube. In this, the lime water will be turning to milky white, saying that the gas evolved here is carbon dioxide. It is carbon dioxide that turns lime water milky. Thus, we understand that when metal carbonate or hydrogen carbonate react with acids, it will be giving salt, water and carbon dioxide gas. When we pass excess carbon dioxide gas through this test tube, it will be forming calcium hydrogen carbonate, which is soluble in water. And this is the third chemical property of acids and bases. So in general, we can say that when an acid reacts with a metal carbonate or metal hydrogen carbonate, it will be forming a salt, carbon dioxide gas and water. Now what about the reaction of metallic oxides with acid? As an example for metallic oxide, let's take copper oxide. And as an example for acid, let's take hydrochloric acid. When copper oxide reacts with hydrochloric acid, it will be giving copper chloride along with water. Are you familiar with this reaction forming salt and water? Yes, it is neutralization reaction. When a metal oxide reacts with acid, it will be forming a salt and water. Thus, we can identify or we can say that the metallic oxides are basic in nature. Now, what about the reaction of non-metallic oxide with a base? As a non-metallic oxide, let's take carbon dioxide, and as a base, let's take calcium hydroxide. When calcium hydroxide reacts with carbon dioxide, it will be giving calcium carbonate and water. That is a salt and water. Are you familiar with this reaction? Okay, this is as similar to the neutralization reaction. And we can confirm that when a non-metallic oxide reacts with a base, it will be giving salt and water. Thus, we can conclude that these non-metallic oxides are acidic in nature. So, in today's session, we have discussed about the 5 chemical properties of acids and bases. One is neutralization reaction, reaction of acids with metals, reaction of bases with metals, reaction of metal carbonates or metal hydrogen carbonates with acids, a reaction of metallic oxide with acids and a non-metallic oxide with bases. So, I hope this session is very clear to you. See you in the next session. Have a nice day. Thank you.